Hello, welcome back. This is Rich Allen again. And as you know, I am kind of a fanatic when it comes to O'Neill cylinders and Stanford toruses. Basically, any design that can enable a humanity to expand beyond Earth's surface. And I'm not the biggest fan of inhabiting a planet. I'm sure, there will be some mining on other planets, and there'll be other reasons to have bases, maybe military or government uses, or some kind of like for entertainment, just to visit different planets and moons in the solar system. But by and large, I'm really certain that O'Neill cylinders are going to be the end game for habitation in in the solar system and beyond. Uh, I think O'Neill cylinders around orbit around the sun, basically, and it could get started with small Stanford toruses and then grow to larger Stanford toruses. Um, but I don't have the time to make the artwork myself, so I'm constantly scouring the internet to find um, like really good artwork, really compelling artwork of what the future could look like. And I gotta be honest with you, I find a lot of stuff. Um, I'm seeing some trends. I'm seeing a lot of stuff from the same few people. That it's interesting, but it's like not great. And then I'm seeing stuff that's like AI content, which is just deplorable. It's just junk. It's not good. I just wish it could be better. But and then I do see some independent stuff that's I haven't seen the particular creator before, and I have a couple videos today I want to go over. I want to watch them with you, and then I want to make my own commentary on how I feel about these particular videos. The first one's 10 minutes long. The person who made it sounds a little bit young, but so I definitely applaud this person for getting in the game. And the next one's pretty good too. So we got about 15 minutes worth of content here. Let's go check it out, okay?
This video is not intended for
Whoops.
children under
I
13
did
years
this one.
old. If you are under 13 years old, please do not watch this video as the topics we discuss are meant for those with at least a high school level of education. If you are not 13, you will not understand the scientific topics discussed in this video. Humans have evolved on a planet with 9.807 meters per second squared of acceleration constantly pressing down on us. Without that pressure, the human anatomy does not cope well. Immediately after exposure to zero gravity, nausea begins to creep in. A person in zero gravity is experiencing that stomach-lifting sudden drop at the top of a roller coaster 24/7. Furthermore, the freedom of motion allowed in zero gravity environments worsens this nausea by adding motion sickness into the mix. Basically, your vestibular system has no idea what is going on when you enter zero gravity. On top of that, zero gravity results in muscle and bone decay. The simple act of standing up on Earth strengthens the muscles and bones in your legs because they are supporting your weight. And whenever you pick something up, your arms are being exercised too. In zero gravity, however, there is no such thing as weight. So you must exercise many times per day to keep your muscles and bones in shape. And even then, it often doesn't cut it. Without the downwards pressure on your body, zero gravity also allows all of your body's fluids to move upwards. This can cause eye problems as your eyes are inundated with excess fluid. Overall, zero gravity doesn't seem so great. It may be a fun novelty at first, and only if you aren't prone to motion sickness, but very soon it gets old. If we want any permanent settlements in space, then we need to give those settlements artificial gravity. The easiest way to do so in known physics is a method using centrifugal force. Using centrifugal force looks a little different on every scale, so let's take a look at these scales. Part 1. We start with the Stanford torus, a donut-shaped ring 900 meters in radius and 130 meters wide. This ring would rotate once every minute and would have a surface area of about 3/4 of a square kilometer. Assuming an urban population density of 2,000 people per square kilometer, this space station could support a staff of around 1,500 people. Whether this specific design is used or something of a similar scale It will be something of early orbital operations. As SpaceX plans to colonize Mars and NASA and Blue Origin focus on the Moon, there will be increasing throughput in Earth orbit. Becoming a hub of travel, it will only be natural for space stations of these proportions to be built in Earth orbit. This would allow increasing efficiency in traveling through space, as a mission can be broken up into two segments, refueling at the spaceport. Early on, these stations could be used for research as well, but the whole point of most research in space is how the absence of gravity will affect some biological or chemical process. With artificial gravity, those experiments are impossible. However, a station could be set to spin at a slower rate to simulate the gravity of the Moon or Mars. Because stations of this size are likely to be small early spaceports, they won't have much in the way of permanent population. That way, bone and muscle decay will not be too big of a concern, and useful research can still be extracted without having to travel all the way to another planet to do so. Furthermore, the lower gravity puts less stress on the space station. That isn't much of a problem at this scale, but at larger ones it will be. Because colonies built like this will spin for artificial gravity, they will have forces pulling on them to fly apart. As long as the tensile strength, or eventually the aid of other forces, is strong enough, then the station will stay together. If not, then a disaster will occur. Life on a space station like this would be transient and cramped, but likely exciting. It is not the ideal size for settlements in space, but it is for an early spaceport. Just as tiny villages gave way to bustling metropolises as humanity developed on Earth, small space stations will give way to larger ones as it develops in space. Part 2. Next is the O'Neill cylinder, a cylinder 4 kilometers in radius and 32 kilometers in length. It would rotate once every 2 minutes to simulate Earth-like gravity and would have a surface area of about 800 square kilometers. That is the surface area of New York City, so an O'Neill cylinder could realistically support 8 million people. On the other hand, it could also have a suburban population density and a population of a few 100,000. Space stations on this scale would mark the first real settlements in space. There will likely be towns and cities much larger than these on the surfaces of the Moon or Mars earlier, but eventually, these colonies will be built. This is especially so with the possibilities of asteroid mining and in-orbit construction. Moving through space is a lot easier than moving from the surface of a body into orbit, so space stations that can be sourced and built in space will be very cheap to build. Billionaires could have these built like private islands, or coalitions of average people that have some reason to want to live in a space station like this could crowdfund them. That possibility is very interesting. Imagine groups of people from around the world uniting over some common ideology and collectively moving to space. That could result in some very unique societal structures, and could aid people who are struggling on Earth. The resources of space are much more vast than those of our single home planet, so the impoverished and downtrodden on Earth can become very powerful with a move to space. For early colonization efforts in space, space stations of these sizes will be predominant. At this scale, the sky would be the ground on the other side of the cylinder, and the sun would likely be a light turning on and off in the center of the colony. This could be disorienting, but then again, that may just be because we aren't used to it. If it truly proves to be too much of a problem, O'Neill cylinders could introduce a permanent haze, mist, or fog to reduce visibility and make the sky a more familiar gray. This could lead to a trend of colonies in the style of suburban towns in the British Isles with cool, misty weather. The sizes of these colonies will not be exact, of course. As time moves on, they will get larger and larger, requiring stronger and stronger materials as well as smarter and smarter architecture. On top of that, as space stations get larger, the thickness of their atmospheres will allow for the sky to get bluer and bluer. Unfortunately, the natural reflectivity of land and water may result in the other side of the colony shining through during the day. The best way to deal with that is similar to the fog method, keeping things partly cloudy most of the time so that the hazy blue-tinted landscape on the other side of the colony is not too distracting. Part 3. After that is the McKendree cylinder, a cylinder 460 kilometers in radius and 4,600 kilometers in length. It would rotate once every 23 minutes and would have a surface area of about 13 million square kilometers. That is more than the area of Europe. So the McKendree cylinder could support 3/4 billion people with room to spare for a body of water. This habitat is of a continental scale. It is as large as a major body in the solar system, but because it would be a hollow cylinder, it would not be anywhere near as massive. This is the upper limit of objects that could be built as a simple shell supported by tensile strength alone. That is because the design is meant to use graphene or carbon nanotubes, the strongest materials we know of, to stay together. Beyond this, other methods will be employed, but that is for another video. Creating a space habitat as large as a continent means creating a habitat that could be occupied by multiple countries. These countries would likely be bound in a loose union just because they are physically separated from Earth. Furthermore, these habitats are likely to come about only when human populations begin to expand at an exponential rate. As humanity fully utilizes the resources of space, population growth will increase, but to drum up the demand for nearly a billion people's worth of space would require a massive population that sees growth in the billions every few years. Without that quick growth, habitats will be built smaller, to accommodate tens or hundreds of millions at a time. However, once population growth becomes quick enough that a project as massive as this one could be fully occupied a few years after its creation without depopulating massive swaths of Earth, it will become worth it. Daily life on a colony like this would be very interesting. The central light of the colony would be as high up as the International Space Station. For added realism, the light could move across the sky throughout the day, down the length of the colony, instead of remaining a solid bar that brightens and dims every 24 hours. This would create different time zones within the colony, though
Let's go
they would
back.
only be a few hours apart from a solid bar that brightens and, for added realism, very interesting. The central light of the colony would be as high up as the International Space Station. For added realism, the light could move across the sky throughout the day, down the length of the colony, instead of remaining a solid bar that brightens and dims every 24 hours. This would create different time zones within the colony, though they would only be a few hours apart from each other. And that is something we already deal with on continental scales, so it wouldn't be inconvenient like it would be in a town-sized object. At this scale, the atmosphere of a colony would decrease in density as one traveled upwards, much like the atmosphere of Earth. This is very different from the pressurized tin cans we were dealing with before. What that means is that there would be a fully fledged atmosphere in the colony, and besides variations in reflectivity on the other side of the colony, the sky would remain a constant blue during the day. Sure, the sky would look darker in places from bodies of water and brighter from clouds on the other side of the world and others, but individual buildings or cities wouldn't offer jarring sights, as they are now being viewed from nearly 1,000 kilometers away. From
Hmm.
here, scales continue to increase, but that is a video for another time.
Hmm. Well, that's pretty awesome. Actually, let's see who this person is. Graviton Media, 3,500 subscribers. They uploaded this video 4 years ago. Probably a little bit older now. Educational content for mature audiences. Huh. Max Rudin. Oh wow, he likes hard fiction basically. Okay, Mr. Rudin. Thank you. All right, let's go back to the YouTube channel. You know, I said I was going to do 2 videos in this one. I think I'm going to just do this one because I'm really impressed with this person. And to be honest with you, I'm really
Journeys
impressed
into
with the other
space are
one.
long and arduous, much like
Tethered rings? Wow, tethered rings. That's wild. Tethered rings. Never even thought of that before. How many? 288 videos. Holy moly. Well, anyway, ladies and gentlemen, please check out Graviton Media. That's really cool. This is an interesting channel. Thank you so much.